Is it up?
Yes.
Right. Awesome.
Good morning and good afternoon, everybody.
Morning.
Morning, Roger.
How are you, Alex?
Good, good. Glad to be back.
Where did you go?
I was on paternity leave. So,
Ah,
yeah, so Jose was filling in last month. Did a great job. Really appreciated that. So also everyone, if you see me yawn, it's not because I'm boring myself to death. So you really like this topic. It's because I'm not sleeping much. Three kids under 5 years old. Oh, not a lot of
congrats.
not a lot of sleep going on for me right now.
I was joking around that, one day there might be robots that just rock your baby to sleep for you.
Yeah, no joke. No joke.
Oh, there are definitely toys for that.
We just
I'm
need them
sure.
to wake up in the night like they would do that.
I'm sure that's what Alex feels like right now. A
There you
robot.
go. The toys that help put the baby to sleep also put me to sleep, so I have to be very careful with them.
Well,
All
all
right.
right. Well, I guess we can go ahead and get started. I hope everyone had a great Thanksgiving last week and that you're able to take some time off. I know not everyone, this is the busiest time of year for us, right? So we here at Plus One had some people supporting Peak, and maybe you guys didn't get the time off. But anyhow, I hope you did find some time with your loved ones on another day. So thanks again for joining us for the sixth installment of our Get a Grip webinar. Today we're going to talk about Robot Jenga. So it's the basics of robotic depalletization. Alex is going to take you through computer vision as it relates to depalletization or depal, and discuss how this is basically a sophisticated form of Jenga in layman's terms. Also, he'll touch on some points that may be new to you, but not so new to robotics necessarily. My name is Lisa O'Brien, and I'll be your host. And just a few quick notes before we get started. We like our webinars to be a little bit conversational. So if you'd like to turn on your cameras, please feel free to do so, just because we want to get to know you. If you have a question, you can either raise your hand and we'll call on you during the presentation, or if you want to put it in the chat, that's totally fine too. We'll try and answer them during the presentation, but otherwise we'll get to them at the end. And then also we'll record this presentation and be following up with you later in the week with an email with the recording and some other materials as well. So before we dive in, let's go ahead and welcome Alex back. Happy to have him back with us. And Alex, I'll go ahead and hand it over to you.
Thanks, Lisa. And also, it is good to be back. All right, we'll jump in here. So, any first-time people here, if you guys have been coming or seen them or been on our YouTube, wherever, then you probably know a bit about me. But for people that don't, I've been here at Plus One for well over 3 years now. I work in the sales and marketing team as an application engineer, and you can kind of read the rest of the bullet points of what I do. And I put some pictures up here in the phrase "teamwork makes the dream work," kind of from Thanksgiving being off for a month and kind of that time of year, reflecting back on how 2024 went, wins, losses, all that kind of stuff. And teamwork really does make the dream work. So there's a lot that goes on in the back end of these webinars. Obviously, Jose, supporting us last month. That's the just some of the teamwork stuff that I've looked at through the years. And so I invite everybody to think about that. Your teams and the teamwork and what you guys were able to produce and do this year. And looking forward to 2025. And that was putting the Depal cell together for Modex this year. So that was a lot of work. So in the spirit of Depal, that's what we're going to talk about today. And I called it Robot Jenga the first time I saw one of the Plus One robotics doing mixed Depal when I first got here. And maybe that comes from when I was learning about robots like a decade ago, and the guy teaching me compared them to dancing and doing all kinds of things that they're not actually doing. So I get a mental image. So I see robots playing Jenga, which we'll get into the details and where I see the similarities in. Again, this will be the basics of it, so don't expect anything super technical. If you have technical questions, obviously feel free to ask. And if you want, you can drop in the comment section. We have a white paper, impact versus rate, which goes into depalletization. in the logistics space specifically, and how to like measure productivity and really measure value of what it can bring to an operation. So if you guys like it, you can reach out or, like I said, drop a comment. Be happy to share it with you. So the agenda today is the first one is the business case, right? Like, is depalletization, like, is this actually a problem? Is there a business case for that, right? Is there that many pallets? Are we doing that much of it? Then we're going to do a little bit of time traveling in there, go back to kind of the 60s and the 80s, and we'll get back into modern times. Then we'll talk about whatever you want to call them, bells, whistles, trim levels, add-ons, all the things that make the depalletization sale do something else that costs money and provide a feature or a value, and kind of understanding where that fits in your operation or with what your needs are or forward looking. Then we're going to talk about playing Jenga with robots and what it needs to know. Um, it seems simple to describe what you're doing, right? Pick this thing off pallet, put it over here. But there's obviously a little more that goes into it. Otherwise, we'd be already doing it everywhere all the time. And then we'll go into edge cases and what do you do to handle exceptions? What inherent are the weaknesses, let's say, of just depalletization, whether it's robotic or otherwise. But we'll go into that in a little detail. Excuse me. And then we'll recap, see if I taught anybody anything. So the first one is the business case, right? And I'll look over here because I got you guys on a different screen today. Is there an actual business case to depaling? Obviously, some of you guys already know the answer to this, but I want to point out a couple of specific things on it. So there's definitely a worker satisfaction aspect to it, to empower your team, to grow your team, to take away the dull, dirty, and dangerous. But sometimes I think it's missed on just like the actual danger of this job. The first problem is, yes, there's a business case because there's somewhere between 7 and 10 billion pallets floating around the world in the supply chain at any given moment of the day, right? It's a big problem. Not all of them are, the whole random mixed pallets and stuff, but there's a lot of pallets with a lot of things that eventually will get taken off the pallet. So eventually they will get depalletized. And this role in warehouses and in other manufacturing and other industries, but this role is critical. If it's on a pallet, it needs to get off a pallet to go to the next step in the process, then it must be depalletized, else you're blocked. So super high turnover position. It's very difficult to hire people for it. Go out there and try. Best of luck. You tell them what you're going to pay them and everything. They say, yeah, and I just need you to take this stuff off pallets all day. And they say, adios. I'll go do something different. Um, on the danger side of it, you can see the statistics down there. This is musculoskeletal disorders, MSDs. All right, hurt back, shoulder, twisted ankle, those types.
Hey, Alex, we can't hear you.
Is that better?
Yes.
Oh, cool. Thanks. So all of those types of injuries, the twisting, the picking, it's heavy, it's over your head, it's down below you, it's awkward. Those are what lead to it, and you can see there in the actual cost, as well as just time out of work, and on top of people seeing their coworkers getting hurt, right? All negative. So business case alive and well on here. And anyone that's been in robotics for a while, and I know some of you guys on here right now have, so you're thinking, yeah, robots have been doing this for a long time, right? They have, right? I think the first robotic depalletizer, we'll call it, was in the mid 60s. It really started taking off maybe in a fuller force in through the 80s, which is the Marty McFly reference, Back to the Future, right? And so it's been around for a long time. But that's not the type of decal that we're going to be talking about today. And that's not the type of decal that AI computer vision is opening the door to. So the type of decal that has been around and that automation's been there is been what's sometimes called delayering, right? You pick a whole layer at a time and drop it off. Single skew, what we could call pattern. You go to a certain spot, you pick a thing up, and every time you just go this mathematical pattern. Rainbow skew could be a variation of single skew. Came from the cola industry or soda industry, where they got like Coca-Cola and Sprite and Diet Coke or whatever, so you have different colors. Those are all can be done without vision. You have a controlled environment coming to the robot, and thus you can put some math to it and some programming and do it kind of similar to palletizing and building single SKU pallets. But this is not a solution in the warehouse. And those pictures are the reason why, right? And the visual aspect of it. Warehouses, logistics, and even other brick and mortar, some of our customers that do brick and mortar, they don't have that much control of how the pallet's built or what's necessarily on the pallet or what it looks like or if it was actually palletized very well at all. If there's things on there that aren't supposed to be there, random slip sheets are one. Been plenty of customer conversations that I've had where they said, "Yeah, we don't really have slip sheets. That's not something that goes to our warehouse." And then we do an automation audit or a site visit, and we see 10% of the pallets have random slip sheets on them sometimes. Sometimes on the bottom of the pallet, sometimes on the top, sometimes just random in the middle. So that is an actual situation where then an operations guy that I'm talking to, an engineer, might be like, "Oh yeah, I guess we do have them sometimes." Well, sometimes is still there, right? So this level of variability and lack of control, lack of influence, even, um, are why the standard way we did it for the last 40 years isn't in the warehouse currently because it doesn't have that control. They need the flexibility that computer vision and AI can give to a robot in real time. I see a thing, I figure out how to pick it, I go. There's also a unique one, or some unique things I've seen over the 3 years with certain customers that we've scaled with. A couple of them that come to mind that I want to point to here, just as to put thoughts in people's heads as they're exploring their automation initiatives, their own challenges in their own warehouses and such. Um, One of them is in ecom furniture, where the issue more resides around they have a whole bunch of items that are in boxes, pretty much all boxes, that are between 50 and 150 pounds. They're very awkward. They don't even come on pallets, they put them on carts, and they needed to take that away from their team because it was a terrible job and people were getting hurt and people would just don't show up on the days that was on their calendar because they just didn't want to do the job, right? And so automating that and putting that back in the hands of the robots and letting people deal with the things that were under 50 pounds, and that were more handleable for people, more ergonomic, went a long way, made impact. And one of the other unique ones was from a Depal straight into the final box in which the item was to be shipped. This was a big business case initiative. This one scaled out well, and I just think it's really unique. I like to bring up the point as we're, a lot of people are just going to be coming into thinking about using robotics in this way. But you could change it. They changed the process. They eliminated steps in the process, make the whole flow more efficient. So that one is it's a cool one to see in person. Seeing picking up big things and putting them in the box and then it's shipping out, getting the packing slip put in, getting taped up. So it's not just the takeoff pallet put on conveyor, right? There's more capability in it now. And the last point I have in there, which is going to lead through the rest of the presentation, is that the computer vision side allows you to take a standard design, let's call it, and put it in many DCs or many locations or through your network, whatever term fits your business. Um, and that allows an inherent whole other opportunity of efficiencies, from the first being that if you train maintenance team or you put a standard operating procedure in place at warehouse A, it can be the exact same for warehouse B because it's the exact same machine, minus maybe small changes in fencing or physical constraint things that have to change, but it's the same robot, same gripper, same vacuum pump, same PLC with controls, same sensors, obviously same vision. Everything's exactly the same. And then also, if you make improvements in one, you want to run a pilot test or change this code or do these vacuum cups or whatever it is you want to test, you find a solution there. You just can put it out on everywhere else because it's exactly the same. And the AI vision side of it is what makes that possible, because the programming can be the same because the decisions are being made on the AI vision side, right, to deal with the variability. So next we'll go in, now that we kind of laid that out and we're talking about scaling and layouts and things like that, and getting you thinking about what might work in your warehouses or in your facilities. Um, I compare this to cars. So again, I'm a car guy. If you didn't see on there, I did BMW race cars for a while, and I liked cars, and I was a car guy before that, just how I got into it. But there's a lot of trim levels, and as the analogy goes, right? What is a base model V6 Mustang? Well, and then there's a Shelby Mustang. Well, they're both Mustangs, right? They're both sports cars, but there's a big difference, and also in price and what they offer. When you're driving them, you'll see the same thing in depalletization. Um, I'll let you guys kind of read the slides on what I put up there, but I want to talk to the points down here where I have the arrows. So, what is the thing that you can buy on the left side, and why would you buy it? What is the need that you have in your operation or your process? That's the solution to it. So if you need more hands-off time, what I mean by that is I don't need a forklift driver dropping off a pallet. Maybe it's a two pallet station. You have a pallet A and pallet B. It picks pallet A till it's done, then it goes to pallet B, and you swap them out. But that's only every 10 minutes I'm coming over here and I'm swapping pallets, and my forklift labor would be better utilized somewhere else. Buffering conveyors, right? However big you want them, I've seen them as small as 2 or 3, all the way up to like 15 pallets where you can load them up and have hours of work ready to go before you need to show back up. Another one, we wanted to go through all of these, but another one is fiducials. One of our customers uses a QR code. Essentially, they put on top the pallets manually. Person looks at it, unstable pallet or super heavy items, whatever you want to do. The vision system can see that, read it, go send a pick point, go remove the label or the fiducial, put it somewhere, and now the robot program can run different. The PLC, the controls. If we see something super heavy, it's okay. All the speeds are slowed down because we don't want to drop things. They're very heavy. You can kind of read through the rest of those, but the biggest point of it is understanding what it is you either need in your process. You definitely need what you want, or forward thinking on there, and not overbuying, essentially, right? Understand what your process is, what you actually need. And there's a ton of solutions out there that a ton of integration companies and even the OEMs breadth of experience for decades, or maybe combine them all, it's 1,000 years, and they understand how to help walk you through that, how to understand your process more in order to kind of get the machine that works. Because vision is handling the variability, it's giving pick points, but again, you can't see how heavy an item is. There's other ways to get around that, force sensors or fiducials, things of that nature, but these features are out there. But not everybody needs the GT, 500 Mustang. Some people just need the regular one. So understanding that is good when you go in there. So far, so good, everybody. All right, I'll make the last point on here, and we'll jump into my favorite part, which is the last point is when you, as a customer looking, or if you're an integrator and you're pursuing efforts on it, one of the things that we've seen that really can make a difference, especially when you're talking about the scale out of an application where somebody may need 10, 15, 20, or 50 of depalletization cells through their network, is understanding their product distribution very well. Um, the One of the best examples that stuck with me for years now, which was the customer said we need to be able to handle up to 75 pounds. We're like, okay, well that starts pushing to this class of robots and whatever, working through a partner. Then we get the product distribution um, sheet back from them. We're looking at all their data, all their SKUs, and it is less than 1/10% that is above 40 pounds. So realistically, 99.99% of their items were 40 pounds or less, which is a whole different class of robots, needed a whole different footprint, whole different, concrete, to anchor it, the cost per system in that scale. I mean, it was a massive improvement to say, hey, customer, would it be fine if we could only pick up 99.99% of your stuff in the super heavy item here? Just handle that one regularly. And they say, yeah, we barely ever see that, like twice a month. Perfect. Now we actually have a business case solution. So looking at your product distribution is very important as you get into this, these machines, because they can get big and expensive if you overbuy. So now the fun part, playing Jenga, right? And this part may sound a little elementary, right? And I do that on purpose. So if you think this sounds kind of childish, on purpose. for human beings, it is not difficult to figure out how to take things off a pallet. Obviously, toddlers take things off of stuff all the time. We've learned how to do this. We're innately know what to do. There's not really any thinking. That's why it's one of those dull, dirty, dangerous jobs. It's all three of them. It's certainly dull, right? But essentially, this isn't a step order of how to do it, but these are points I want to make to put the thought, right? The only thing you're trying to do is just take the items off the pallet. It can be single picking, it could be multi picking, it could be layer picking, it could be the old stuff, it could be advanced things like we do, but you just want to take things off the pallet and put them somewhere. In the process of doing that, do not knock over the pallet and do not make things fall off the pallet. That will make a useless system if you do it very often. And then on top of that, you need to always be picking. The robot needs to be moving. Standard kind of robotics ROI there. If the robot's not moving, it's not being productive, it's not paying itself back. But don't always be picking if the thing you're going to pick is make it fall. So have some discretion in there. Never put the wrong thing on the outbound. Slip sheets are kind of the big, poster child of that. If you put a slip sheet on the outbound conveyor, you're going to have a bad day. Bad things are going to happen downstream. And then also always move super fast. And when you pick up something, keep the robot moving fast. This giant robot here can move at what it may be, 2.5 meters per second, but don't drop anything. So only move as fast as you can hold on to it. And then also you need to recognize when situation's not right, which is what you saw here. This is a crazy angle for the robot to go to. Obviously, if you're familiar with us, you know that was yonder human in the loop, but don't go there. This doesn't make sense why you would need to tip at 30 degrees to go pick something off of a pallet. And then size-wise. And this is not everybody's got the problem, but you need to know what the size of the item you're picking up is. If you put an item that's bigger than the outbound or it's going to get jammed, again, you're going to have a problem. So how do you make it happen, right? You're not going to do it without vision. Fair enough. You're not going to do it without vision. I'll still stand by that statement. You could have 400,000 photo eyes, maybe. Maybe you can make it do it. But what you need to do is you need to be discretionary as a person is in their decision making on when and how they take things off of a mixed pallet. It's not a pattern, right? It's a decision every time. So obviously you'll see highlights from pick one, our vision system, because I have access to give you guys the images from it. But you need to only pick things off the top layer. And obviously, after you clear that layer, you'll go to the next layer. You clear that layer. The reason being is because if you have, maybe you guys can see my hands, if you have something down here and you say, oh, well, this is the closest to the play zone or whatever, I want to go pick it, and then you pick it, but it's actually underneath something else, well, you're going to topple the pallet, right? Rule number one, like, don't topple the pallet. Don't knock it over. If you knock it over, now we're not doing any work. Someone's got to clean it up. Could have damaged any of the items. You could have damaged any of the equipment. Never knock the pallet over. So the best way to do that is don't go digging deep in a pallet. Only pick from the top and don't knock it over. And you see my last point in there? It is Robot Jenga, right? You lose the game when you pull the block out and it falls over. Same thing with Depal. Don't knock the pallet over. Then on the next one, in order to continue to support not knocking the pallet over and, real-time decision making, you need to have the ability to always start in this, let's call it the smart spot, in the correct spot. Obviously, pick at +1, we have pick one, which has a feature in it, which in this older version is still called place transform. But we're going to tell the vision system, this is where you're going to go place the thing. And then it can make a decision based on that of where I should start picking the pallet. So you should pick a pallet. Or how about the opposite example? If I went to the farthest point away on the pallet and picked an item and tried to pick it all the way up, carry it over the entire pallet and put it down, can that be done? 100% that can be done. At what point are you going to make a mistake or something's not going to go perfectly right? And now the result of that is you knock the pallet over. But if you start on the corner, the closest corner, let's say in this case, and you start picking from there and you start clearing things out, so you're not carrying items over other items, you're not running into you're not making every pick a super risky pick. Because again, if you're knocking over one pallet out of every 100, you're not very useful. You need to have a higher level of robustness than that. And one of the ways to do it is in the decision of how you're going to, what we say is decant, but how you're going to depalletize it. There's a pattern to it. There's a place to start that's better than others. So the vision system needs to support that. Or needs to support the robot in the decision that's made on what to go pick. So far, so good. I can't see the comments, so at least if anybody pops in, Just keep me abreast.
Yes.
Thanks.
Okay. So far, so good.
The next one is in mixed depal, especially, um, but in other forms as well. But in mixed depal especially, your gripper is going to be bigger than some percentage of the items that you're picking, and it could be quite a large percentage, right? Even a majority, in some cases, of the items that you're picking. So what are you going to do about that? You can have zone grippers that only turn on certain cups, and there are those methods, and those are good, you know, to support it. But realistically, the best option is don't let the suction cups, quote unquote, the gripper, right? Don't let them touch items they're not supposed to pick. And the vision system knows what it's going to pick, whether that's multiple items or in this case, a single Cheez-Its box. It knows like where it'll fit on the gripper. So what you see in on the left side is the center of the gripper and the center of the package lined up, right? The centroids. So, yep, we got it. Well, in that case, I kind of cut that white line across there. You can see that there's a whole bunch of cups hanging off inside the pallet. In this case, fortunately, not touching anything else. But then there's a whole row of cups touching another Cheez-Its box, which on Cheez-Its, it's not heavy. It's definitely going to pick it up. Will it hang on to it all the way over to the play zone without dropping it? Who knows? You definitely didn't get a good pick. And then having the vision system say, I recognize that I'm going to touch things that are not to be picked up. Let me look around and see where I could move the gripper so that it would only touch things that it's supposed to pick up. Thus, you get what we call an offset pick. But it's to make sure that the suction cups will only ever touch the item or the items in which you're going to pick up. Again, hypercritical because you're not supposed to knock things over. You're not supposed to drop things. Or again, potentially bad enough, damage items because you crushed a gripper into them. So again, these are super easy things for people to do. When we talk about how robotics do it, this is where it becomes the advanced. This is why this has only been around for 5 or 6 years. They also, the vision system, again, has to support it. You can do it with photo eyes. There are other pieces of automation out there that have been doing it for decades that say, if you have this process that's super controlled, just, we could put a sensor in here, we can do these things, we can understand that the pallet's empty. But with computer vision, you can take that to a whole new level of, say, fidelity or capability, where the vision system can say, I see a pallet. It is a pallet. Pick one. We'll generate a pick point. So if you had a gripper capable of picking pallets, that was part of your process, you could just have the gripper, the robot go and move and stack a pallet. But I see the pallet. I know it's a pallet. It's not nothing to pick. It is something. It is, but it is a pallet, and then the system can handle that as the process needs it. In the warehouse space and logistics space, over the years, what we've been able to develop and what we found out, as a necessity is that pallets look a lot different, even wood pallets. They have different numbers of slats and they're different colors. There's a lot of broken pallets. Things come double stacked. Some processes even are built and designed around that for like a manual forklift driver to put after an empty pallet to just put another 5 foot pallet on top of that and another 5 foot pallet on top of that. So when they do the removing of the empty pallets, they remove more than one at a time to be more efficient. But the vision system can understand that this is an empty pallet, which is different than I don't have anything to pick. I do have something to pick. It's a pallet. Do you want to pick it? Which folds kind of into the next one, which is the slip sheets. In the same way that this kind of GIF is pretty simple, it's just a big brown paper slip sheet, kind of your, I don't know, standard slip sheet, if you can call it one of those. Those are common. You'll need to see those. But what we've seen in the logistics space, and even some of our other customers that just supporting their brick and mortar locations, home goods, home repairs, that type of stuff, they have a huge variety of slip sheets that again that are just random. There are times that it's a blue slip sheet and it's half size or a quarter size. There are times that it's a slip sheet like these green boxes. That's just one of these green boxes someone ripped apart and made a slip sheet out of. So the vision system in logistics is going to need to be adaptable enough, flexible enough, and knowledgeable enough in combination with plenty of other, pieces of automation like force sensors. If you pick up a slip sheet, it's really not any weight. And it's like, hey, I don't know. You told me it's a 40 by 40-inch thing, and I picked it up and I've got 0 pounds or less than 1 pound. Something's wrong. This is obviously not an item, but you have to handle slip sheets appropriately. I don't think it takes much of an imagination to think about what happens if you put this big piece of paper on an outbound conveyance system that went through the warehouse of where it's going to jam up, what it's going to block, get on sensors or other factors. So your ability to handle slip sheets is paramount for most applications, most processes. So if you have those in your facilities and you're looking into this automation, understanding the variety and variability in your slip sheets, whether they get damaged or stained or come in colors or have edges, is very helpful when you're looking into what the solution is going to be to solve your problem. And then this last one didn't make it up on the list, but I want to touch the point. Uh, if I told you that I could give you a robot that picked 1,000 cases per hour, this Depal robot can do 1,000 cases per hour, and you're like, fantastic. That's even better than what I need. The ROI is going to be, 72 hours on this $1 million system, right? This is game changer. But your downstream process can only support 600, whatever that may be, through hardware, through labor. The general process of understanding when multi-picking is applicable and useful is around downstream. So you'll see I have it in there. Um, oh no, I guess I took it out here. But the downstream process is the bottleneck. If it can support it, it's great. It can really increase throughput, which is obviously going to reduce payback time. But it's also dependent on your product distribution. And if you never going to end up with things that are leveled up, if all your pallets are 4 or 5 inches of height differential between every item that's touching, you're really not going to get a lot of multi-picks. But if a vision system is capable of supporting that and saying, hey, here's 2 items to pick or 3 items to pick, being able to understand that you're picking the multiple items and what you want to do with them and how you want to handle them, you can get numbers out here that help with those kind of those critical time windows in which you have to be able to depalletize. Right? We don't have all day to sit around and watch this robot, go slow and pick them one at a time. Some cases we have a 4-hour window or a 6-hour window in which we need to get this much done. Or maybe it's 16 hours, but we need to go through all 500 pallets every 16 hours. So whatever that may be, I like to highlight that this feature is now capable with advanced vision, not only in the counting of items, but the ability to discern when you can and can't multi-pick an item. Which brings us to my final point on the agenda in the edge cases. And what do you do when you don't know what to do, or when the decision of what to do, like in the top right case over here, which is this highly tilted item, which we saw a video of earlier. What do you do with any of these edge cases? Because in the mixed depalletization world, especially when you get into the warehouses and logistics space, it is such an extremely variable environment with a multitude of an endless long tail, if we're talking about the long tail problem, an endless long tail of damage and changes. You don't know when Quaker Oats is going to put it in a whole new box of a different shape, of a different color, with different designs. You don't know when you're going to end up with these shiny metal cans. There's just a huge variability on what you're going to get. So the number of edge cases and the frequency in which you encounter them is high enough to where if you can't handle the majority of them, again, you're not going to be, what I say there, good for an operations team. They're going to have to spend too much time helping a robot out. And there's not really a lot that you can do in Depal except like pull the pallet out, which some situations is easier than others. If you have auto pallet buffering and things like that, it can be a real problem. So if y'all thought from my other one, Help I've Fallen, I Can't Get Up, I was going to do a life alert picture, I was. So if anyone thought that, you're on the same page. But then I saw all the pictures and they made me too sad. So I just put this cute dog down here because I thought it would be a lot funnier. But what happens, right? What can you do? So Depal systems, unlike parcel induction, where we also spend a lot of time in robotics, and there's other applications out there too, each picking out of totes, right? How many times can you keep stirring the tote or shuffling a tote until you finally find in each item that the vision system and the logic agree is a pickable thing? Well, how many times can you shuffle a pallet? Right, 0. I mean, what can you actually do if the vision system or the controls automation, whatever, says, I got nothing to pick? I mean, the robot is stuck. And if we take the extreme example of it's a single robot with a single pallet to pick from, the only pallet location. There's no other options to go to a different pallet. There's no automatic pallet, movement to an external buffer. It's just a pallet sitting here. What are you going to do if you got nothing? If you have items that need to be depalletized, but it can't come up with a pick point? right? It is completely stuck up until the point of when someone could come fix it, right? Your bot tender aspect. We don't really like that at Plus One because people are buying robots because they're trying to upskill their labor. They're trying to maximize their labor, for efficiency. So coming and helping a robot out all the time is not really doing that. Again, I got a quick math thing there. I was just saying 50 items per pallet. Oh, if you got 99% of the time, you can do all the edge cases, but 1% of the time you can't do those at all. I mean, you do the quick math, right? 100 items. Well, one item. There you go. That's two pallets. Now you need help. So understanding as you're looking into, again, your product distribution, when we're doing layout, the computer vision aspect, the AI aspect of it can take and open these doors for opportunities in variable environments that are frankly impress me. And I've been around robots for a long time. It's really cool. But there's still edge cases that exist out there. Human in the loop is the best solution to that, hands down, because you want to eliminate the need for people to pick up the heavy, bulky items. You want to eliminate the walkback time to support the robots so that the people that are doing their job can stay doing their job. Obviously, if you've been on some of the other webinars where we've done a deeper dive into Yonder, our human in the loop software, you would understand how, it can improve AI, can improve iterative improvements over time, through design changes and things like that. But the human in the loop says, "Oh, you don't know what to do with this because it's at 30 degrees," and the control system says you're not allowed to pick an item that's that crooked. Makes no sense why it's here. But a human looks at it and says, "Yeah, it's just a crooked box. You can pick it. I'll give it." It goes, picks it. Oh, now everything's great again. I'll go ahead and finish this palette and the next one and the next one and the next one and another problem. Hey, this is a slip sheet, but I'm not super sure it's a slip sheet because it's got this cool pattern on it. Oh, that cool pattern was just an oil stain that happened to look like, you know, whatever the picture is. And they ask, like, yeah, I'm kind of confident it's a slip sheet. And a person says, yeah, that's definitely a slip sheet. Label slip sheet, go take care of it. So because in Depal you're so constrained on heavy pallets on what you can do with them, if you can't pick a thing, if you can't get vacuum on an item, for example, because it's damaged, human in the loop it really, really shines in this application. Shameless plug for us in Yonder, but I've seen too many of them now and I've been out there looking specifically into depalletization for years with our customers and rolling them out, and it makes such a huge difference. All right, I'm gonna recap it up. I know I'm coming on time. Uh, and hopefully, I gave you guys some kind of new aspects of ways to look at this, but there are there's a huge business case for it because there's billions of pallets. We know e-com is growing. We know that supply chain's getting pressed harder and harder, and the expectations are higher and higher. So there's just going to be more and more pallets, right? It's a very efficient way to move things around. We know that the job's critical, as I said earlier, if things need to get off this pallet to go to the next step of the process, until they get off the pallet, you are blocked. And people don't want to do the job because the job is difficult. Exceedingly high injury rate compared to other jobs in the warehouse, especially, but even amongst other types of jobs like construction, it's unusually high, excessively. And this is not a new application of robotics. This is the the new capability. I still think that's the best way I can say it. The AI computer vision is not bringing in a new way to use a robot in a sense, right? Robots have been doing deepal for decades. So the technology that's used in that has been around for decades, has been proven, has been iterated on, has been made better in designs. What AI Vision's bringing is new capabilities. Now I can make a decision every single time I need to pick something. So we have customers that have scaled out with systems powered by our vision, and it may have a day where it does nothing but single skew, and then the next day or the next 3 days, nothing but random, and then single skew again, or all mixed between the two of them. It brings that capability and flexibility into what the operations teams needs. So the capability, not the new application. And obviously, we've got to be versatile and flexible. Kind of been through that on here, but obvious if you work in a warehouse. The biggest one, the last one that I'll really hit on, you can't knock over a pallet. You can't knock them over. You cannot do it. It is Jenga. You knock over the pallet, you lose. And lastly, my other one, people want to buy something, green button on, work all day on my job, red button, go home. Human in the loop is what allows Depal to do that. Without it, you get stuck way too much.
Awesome. Thanks, Alex. Really quick, are there any questions out there? I've got a question for you, Alex. If a robot can depal, can it be turned the other way and also palletize?
Theoretically, sure, theoretically. So I'll start with the theoretically on that one. There are different processes. If I was going to say, do I know about one that can do that, and you could just go buy it now? No, I don't. I don't know that that exists anywhere in the mixed case world, right? Single SKU palletizing and depal, it totally way more doable. In the mixed case world, not so much. And it has to do with taking things off of a pile versus building a pile type of problem. So the processes are a lot different. The easiest example is it does not matter on depal if I pick up an 80-pound box first and put it on the outbound conveyor or AMR or whatever it's going to. It doesn't matter that I picked up an 80-pound box and the last thing I picked up was a 5-pound box. It's irrelevant. I'm taking a pile, I'm singulating it out. But building a pallet outside of the technical differences there in the Tetris game and optimization and pack density, outside of those technical things, which are different, it does matter. It does matter a lot that you brought me an 80-pound box to put on top of a 8-foot pallet of a bunch of 5-pound boxes. It's not going to be stable. So the short answer is no, I don't think that that exists out there because the processes are too different. But in single SKU, like a manufacturing setting, it's reasonable. Well, good question. Uh, one day, maybe somewhat soon, we'll get there.
Alex, I have a question. This is Roger.
Yeah, what's up, Roger?
Hey, in terms of Yonder, which, I think it's a wonderful tool. How many, or I don't know if you can share this, but do you offer let's say an on-site Yonder outfit that the customer can manage or
Mhm.
or monitor, or do you do it all through your own crew chiefs at your
Yeah, so
facility?
no, good question. Right now, so technically, we have a few line items on Yonder, right? The standard kind of one that is sold and subscribed to is +1 is your crew chief. When your robots, wherever they are, ask questions, we have people staffed, and your question will get answered, or your robot will get its request answered in whatever our agreement time frame is. Generally, something like 30 seconds, although generally happens a lot faster, like 10 seconds. But that's the normal way it goes. That's the vast majority of all of them. But we are happy to allow customers and give them the login and give them the training, and they have their own people be their crew chiefs. Sometimes it's on site, sometimes it's in like in their Pittsburgh facility, but they're managing their robots through the whole United States or Europe. So that's otherwise works exactly the same, just different login names, but features, and then we train them and we support them in their not that it's a super difficult thing to learn how to use our interface, but there's just things that our guys have been doing for a long and girls have been doing for a long time. They're like, when you see a depower robot and it looks like this, do this thing. See, that's really what the problem is. So this is the solution. So it helps. And then there's the third one, which is less common, but sometimes required by certain customers, where we just set up an on premises server. So there's some drawbacks to that, obviously not being actually connected to the internet and the cloud, um, where they do their own crew chiefing in a building because nothing's allowed to leave the building. So we have all kind of three bases covered.
Thank you. Helpful.
Yeah, no problem, Roger.
All right, we got another question in the chat. The question is, what's brewing for 2025? What kind of improvements can I expect to see a year from now?
Ooh, so I'll have to be careful, more careful with this one. In 2025, there's a lot of things that are happening. On the decal side specifically, I'll stick there, so I'll watch my tongue on this one better. On the decal side, um, you're going to probably see some more announcements, and depending on how that shakes out, I don't do the marketing on here, but inside of the expanded capabilities of our vision system and what we generally call grocery decal, but specifically on those items that topside grasping is not um, the useful strategy where you're going to need some other rear support, side support, or grasping. So do you think of like your canned goods and things like that? So I know that is going to be something that we're going to be able to shake up some news on in 2025. Uh, I've got some things I'd love to tell you, but I'm not going to do it on a webinar that's going on the YouTube. Sorry, but we do have some cool stuff. Obviously, there's the standard improvements on, again, our cadence with, Yonder and AI improvements and general model improvements, standard improvements on interfacing for both our partners, our end users, in some cases on interfacing with the vision tech. And data improvements on what we gather and what we can feed back into, so how quickly we can respond to stuff. Um, but all my big news, I don't know. I should have run it by the CTO first. I'd have to run it by Sean first. But we do have some big news coming out in 2025, some good stuff. So keep your eyes out on LinkedIn and on our newsletters.
I think that's a good answer. Yeah, you guys will just have to stick with us a little bit
Yeah.
and wait and see. So, all right. We're at time. So I went ahead and put the registration link for our next webinar in the chat. You'll see emails for that as well. And then if you still have questions, please feel free to reach out to us. You know, Alex, I think his contact info should be on the next slide.
Yeah.
We also have someone on our team who will reach out to you if we aren't familiar with you. We will assume you've got some questions and maybe want to continue the discussion. But that's it, and that's it for us for 2024. So thanks again for taking the time to be with us. Happy holidays to everybody, and we'll see you in January. All right. Bye, everyone.
Thanks, Lisa. Thanks, Alex.
Thanks.
Got it,
Bye.
Roger. You
Thanks,
guys have a
guys.
great December. Happy New Year's.
Thank you. You too.
Everybody leaves. So, in